March 3, 1974. A cargo door rips off a DC-10 over France. The cabin floor collapses. 346 people die in the Ermenonville forest. It is the deadliest single aircraft disaster in history. Later, investigators discover McDonnell Douglas knew about the flaw for years. They had cut corners on safety to stay on budget. That plane would go on to sell over 400 units and continue flying for 49 more years. Production continued. Airlines kept buying it. The plane they rejected? The Lockheed L-1011 Tristar. It could land itself in zero visibility. Its reliability hit 98.1%. Pilots called it the greatest airplane ever made. It never killed anyone due to design flaws. And yet, it destroyed the company that built it. Lockheed needed to sell 500 TriStars to break even. They sold 250. They lost money on every single one. The failure was so catastrophic that Lockheed abandoned commercial aviation forever. It never came back. The flawed plane thrived. The perfect plane bankrupted its maker. How does the most technologically advanced airliner ever built, an aircraft so beloved that pilots wept when they retired it, become the greatest commercial failure in aviation history? To understand, we need to go back to where Lockheed's nightmare began, with a different plane entirely. In 1959, Lockheed was on top of the world. Their military aircraft were legendary: the U-2 spy plane, the SR-71 Blackbird, the F-104 Starfighter. When it came to pushing technological boundaries, no one touched Lockheed. Their Skunk Works division was the most elite aircraft design team on the planet. But Lockheed wanted more. The commercial aviation market was exploding. Boeing had the 707. Douglas had the DC-8. Lockheed saw billions in potential revenue, and they had what they believed was the answer: the L-188 Electra, a turboprop airliner that would bridge the gap between propeller planes and pure jets. Then the Electra started falling out of the sky. On September 29, 1959, Braniff Airways Flight 542 disintegrated over Buffalo, Texas. The left wing simply tore off in mid-air. Investigators were baffled. 6 months later, it happened again. Northwest Airlines Flight 710 broke apart over Indiana, killing all 63 people aboard. What followed was one of the most intensive aircraft investigations in aviation history. Engineers discovered a phenomenon called whirl mode. The Electra's engine mounts could fail after repeated hard landings, reducing the stiffness of the engine nacelle. When this happened, the propellers would begin oscillating at a specific frequency that matched the natural vibration of the wings. The propeller blades would start spinning in an increasingly violent circular motion, and the resonance would build until the wing tore itself apart. It was a design flaw so subtle that it had escaped every test, every simulation, every engineering review. Lockheed spent $53 million, equivalent to over $560 million today, reinforcing every Electra ever built. But the damage was done. No airline would order another one. Lockheed had built only 170 Electras. The company retreated from commercial aviation, humiliated, swearing they would never return. For 7 years, they kept that promise. Then, in 1966, American Airlines came calling with a problem. The Boeing 747 was too big for most routes. The 737 was too small. American needed something in between, an aircraft that could carry 250 passengers on transcontinental flights from New York to Los Angeles and from Dallas to London. American's chief engineer, Frank Kolk, contacted the 3 major aircraft manufacturers, Boeing, Douglas, and Lockheed. Boeing was consumed with the 747 and 737 programs, so they passed. Douglas, newly merged with McDonnell Aircraft, was interested. Lockheed, still stinging from the Electra disaster, saw an opportunity for redemption. What happened next would define the future of commercial aviation. Douglas and Lockheed both submitted proposals for nearly identical aircraft, wide-body trijets with 3 engines, seating around 250 passengers. but their philosophies could not have been more different. McDonnell Douglas approached the DC-10 with one guiding principle: stay on budget. Cost overruns were unacceptable, even at the expense of safety. They reused as much technology as possible from the DC-8. When they needed to mount the third engine in the tail, they chose the simplest solution: bolt it directly above the fuselage, exposed to the airstream. Lockheed took the opposite approach. If technology did not exist to make something work, they would invent it. Every single component of the L-1011 would push the boundaries of what was possible. When they mounted their third engine, they designed an S-duct, a curved inlet built into the tail that fed air to the engine through a graceful arc. It was more complex, more expensive, and more difficult to manufacture. But it reduced drag, improved stability, and created a quieter, more efficient aircraft. This decision to pursue perfection over practicality would echo through every choice Lockheed made. But here is where it gets complicated. Both aircraft needed 3 engines because of the FAA 60-minute rule. Twin-engine aircraft could not fly more than 60 minutes from the nearest airport, making transcontinental routes impossible. 3 engines solved this problem with enough redundancy to satisfy regulators. Both Lockheed and Douglas converged on identical configurations because they were solving the same problem. But while the configuration was similar, the execution was radically different. And Lockheed's execution began with the most important decision of all: the engines. Lockheed's engineers had specifications that seemed impossible. They wanted an engine that was quieter than anything flying, more fuel efficient than any competitor, and lighter than any engine in its thrust class. Only one company claimed they could deliver: Rolls-Royce. Rolls-Royce proposed the RB211, a revolutionary design that would change aviation forever. While competitors like General Electric and Pratt & Whitney used 2 spool engines with 2 sets of rotating components, Rolls-Royce designed a 3-spool engine. 3 independent shafts, each optimized for a different part of the compression and combustion cycle. The 3-spool design offered enormous advantages. Each shaft could spin at its optimal speed, improving efficiency dramatically. The engine could produce more thrust while burning less fuel and generating less noise. And to make it even lighter, Rolls-Royce planned to construct the fan blades from a revolutionary carbon fiber material called high-fill. On paper, the RB211 was a masterpiece. It promised a better power-to-weight ratio than any engine in existence. Lockheed's engineers were mesmerized. They signed an exclusive contract with Rolls-Royce. This decision locked Lockheed into a single supplier, one of the most dangerous positions in manufacturing. If Rolls-Royce failed, Lockheed would have no backup. The S-duct they had designed was specifically sized for the RB211's smaller diameter. A General Electric CF6 engine would not fit. A Pratt & Whitney JT9D would not fit. There was no plan B. But Lockheed believed in Rolls-Royce's engineering prowess. After all, this was the company that had built the Merlin engine that won the Battle of Britain. What could possibly go wrong? February 4th, 1971. The impossible happened. Rolls-Royce declared bankruptcy. The revolutionary RB211 had become a money pit. Development costs had doubled, then tripled. The high-fill carbon fiber fan blades kept failing bird ingestion tests. Birds would strike the blades and shatter them into pieces. Rolls-Royce had to redesign the fan using titanium, adding weight and cost. By January 1971, the company had burned through every pound it had. Lockheed was paralyzed. They had a beautifully engineered airframe sitting in Palmdale, California, ready to fly. They had $652 million invested in development, and they had no engines. Worse still, Lockheed itself was in a financial crisis. The C-5, a military transport program, had experienced massive cost overruns. The company's liabilities exceeded its assets by $38.5 million. Banks refused to lend money without government backing. What followed was a high-stakes diplomatic chess game between 2 governments. The British government, under Prime Minister Edward Heath, agreed to nationalize Rolls-Royce and restart engine production, but only if the American government guaranteed Lockheed's survival. If Lockheed collapsed, there would be no customer for the RB211. Rolls-Royce's rescue would be pointless. In Washington, Congress debated the Emergency Loan Guarantee Act. It would authorize the government to guarantee $250 million in private loans to Lockheed. The vote in the Senate was tied 49-49. Vice President Spiro Agnew cast the tie-breaking vote in favor. Lockheed survived by a single ballot. But the damage was catastrophic. The engine crisis had delayed the L-1011 by 18 months, and every day of that delay was a gift to McDonnell Douglas. August 5, 1971. While Lockheed struggled to get its engines, the DC-10 entered commercial service with American Airlines. McDonnell Douglas had made their aircraft work with General Electric's CF6 engines, engines that already existed, engines that didn't require revolutionary new technology, engines that delivered on schedule. The DC-10 wasn't as sophisticated as the TriStar. It wasn't as quiet. It wasn't as fuel efficient. But it was flying, carrying passengers, generating revenue. When the L-1011 finally entered service with Eastern Airlines in April 1972, the DC-10 already had a year head start. Airlines that might have waited for the superior TriStar had already committed to the DC-10. McDonnell Douglas had captured market share that Lockheed would never recover. But here's where the story gets even more explosive. Remember how McDonnell Douglas designed the DC-10 to stay on budget, even at the expense of safety? That philosophy would reveal itself in the most horrific way possible. The DC-10's rear cargo door used an outward opening design with an electric latching system. Unlike the L-1011, which used 4 independent hydraulic systems with redundant controls routed through multiple pathways, the DC-10 routed its control cables through a single vulnerable location directly under the cabin floor above the cargo compartment. On June 12, 1972, an American Airlines DC-10 was flying over Windsor, Ontario, when the rear cargo door blew off at 12,000 feet. The explosive decompression caused the cabin floor to collapse, severing control cables. The pilots barely managed to land the crippled aircraft. No one died, but the flaw was now known. McDonnell Douglas issued a service bulletin recommending modifications, but service bulletins aren't mandatory. Airlines could ignore them, and many did. On March 3, 1974, Turkish Airlines Flight 981 departed Paris with 346 people aboard. A baggage handler who couldn't read the English or Turkish warning labels closed the cargo door. It appeared locked, but wasn't. At 11,000 feet, the door exploded outward. The floor collapsed. The control cables severed. The DC-10 plunged into the Ermenonville forest at 500 miles per hour. It was the deadliest single aircraft disaster in aviation history at that time. The L-1011 never suffered a similar catastrophe. Its design was inherently safer, but airlines kept buying the DC-10 anyway. The technical superiority of the TriStar bordered on science fiction. The L-1011 was the first wide-body certified for Category 3C autoland, completely blind landings in zero visibility. While other aircraft diverted when fog rolled in, the TriStar could descend through soup so thick pilots could not see their wingtips, touch down on the centerline, and roll to a stop without any human input. But Lockheed did not stop there. They invented direct lift control. On normal aircraft, pilots adjust descent rate by changing pitch angle. Direct lift control used spoiler panels to adjust lift without changing pitch. Approaches were silky smooth. On May 25, 1972, test pilots Anthony Levier and Charles Hall demonstrated the impossible. They flew 115 people from Palmdale, California to Dulles Airport in 4 hours and 13 minutes, with autopilot engaged from takeoff to landing. Human hands never touched the controls. It was the first cross-country flight in history completed entirely by autopilot. The TriStar also featured a below-deck galley served by elevators, corrosion-resistant autoclave-bonded fuselage panels, and a cabin so quiet that Eastern's Whisperliner nickname became official marketing. This was the plane that could not sell. By the mid-1970s, Lockheed was desperate. The DC-10 was outselling the TriStar nearly 2-to-1. Something had to change. What happened next would become one of the most infamous corporate scandals in aviation history. Lockheed hired Yoshio Kodama, a Japanese ultranationalist with ties to organized crime, as a consultant. His job was to convince all Nippon Airways to switch from the DC-10 to the TriStar. Money flowed through layers of intermediaries, approximately 2.4 billion yen, with 500 million yen going directly to Japanese Prime Minister Kakue Tanaka. On October 30, 1972, all Nippon Airways announced it would purchase 21 TriStars. In February 1976, a Senate subcommittee led by Frank Church exposed everything. Tanaka was arrested. Lockheed's chairman Daniel Horton and President Carl Kochian resigned in disgrace. The scandal spread across the globe. Prince Bernhard of the Netherlands was implicated in accepting over $1 million. The perfect airplane now had a criminal record. But the bribery scandal was merely salt in the wound. The TriStar's fundamental problem was market dynamics, and no amount of technological superiority could overcome it. General Electric had continued developing the CF6 engine that powered the DC-10. Within years, they offered higher thrust variants that allowed McDonnell Douglas to introduce the DC-1030, a long-range intercontinental version with substantially greater capability. Airlines could now fly DC-10s across the Atlantic and Pacific. Rolls-Royce, still recovering from nationalization, struggled to develop higher thrust versions of the RB211. The engine that had nearly bankrupted its manufacturer required years of careful, underfunded development before the RB211-524 could match what General Electric offered. Even then, the TriStar faced a fundamental limitation. The DC-10's design allowed for substantial increases in maximum takeoff weight, over 60 tons of additional capacity through structural modifications. The TriStar's more elegant, lightweight design could not be scaled up as easily. To add range, Lockheed had to shrink the aircraft, trading payload for fuel capacity. The L1011-500, introduced in the late 1970s, was actually shorter than the original, sacrificing seating capacity to achieve the range airlines wanted. It was an engineering compromise that admitted defeat. In 1981, Lockheed made the announcement everyone had been dreading. Production of the L1011 TriStar would end. The 250th aircraft, already on order, would be the last. They had needed 500 sales to break even. They had achieved exactly half that number. On August 5, 1984, Lockheed delivered its final TriStar. The ceremony in Palmdale marked the end of an era, and the end of Lockheed's commercial aviation ambitions forever. McDonnell Douglas, despite the DC-10's safety scandals, had sold over 400 aircraft. Boeing had sold hundreds of 747s. Lockheed, with arguably the finest commercial aircraft ever designed, had been obliterated. The company retreated to what it knew best, military contracts. Over the following decades, Lockheed would build the F-22 Raptor, the F-35 Lightning, and countless classified programs for the Pentagon. They merged with Martin Marietta in 1995 to form Lockheed Martin, now the world's largest defense contractor. They never built another commercial airliner. But the TriStar story doesn't end in 1984. Many of those 250 aircraft flew for decades after production ended. Delta operated TriStars until 1995. British Airways flew them through the 90s. And one TriStar, number 67 off the production line, found a second life its designers never imagined. In 1992, Orbital Sciences Corporation purchased a former Air Canada TriStar and renamed it Stargazer. Modified to carry the Pegasus rocket underneath its belly, it became the world's first privately developed orbital launch platform. As of 2025, Stargazer remains in service, the last L-1011 TriStar still flying. The aircraft that was too advanced for commercial aviation now launches satellites into space. The lesson of the TriStar is brutal. In commercial aviation, timing beats technology. Being first beats being best. The market doesn't care if your autoland system is revolutionary. It cares whether your airplane is available when airlines are writing checks. Lockheed made every decision correctly from an engineering standpoint. They designed the quieter aircraft, the safer aircraft, the more efficient aircraft. Pilots who flew both unanimously preferred the TriStar. And none of it mattered. The TriStar's legacy is written in contradictions. The safest wide-body of its generation was outsold by an aircraft that killed hundreds through design flaws. The most advanced autopilot ever created couldn't navigate the treacherous waters of market competition. The company that invented the future of flight was destroyed by it. Lockheed built the perfect plane, and the perfect plane destroyed them. Sometimes, being too good for this world isn't just a metaphor. Sometimes, it's a business case study taught at Harvard and Wharton as a warning. Sometimes, a masterpiece is precisely what kills you. The L-1011 TriStar was Lockheed's magnum opus. It was also their epitaph. And somewhere over the Pacific, Stargazer still flies, the last TriStar carrying rockets into the heavens, a ghost of what might have been if the greatest airplane ever made had only been good enough.